good. Okay, so tutorial 14, question number 1. We start with the objective question. Based on the first law of thermodynamics, in which equation is Q equals to delta U plus W? So this one is the first law of thermodynamics equation. Which of the following statement is correct? Okay, mana satu yang betul?
C sir yang betul.
So the answer is C. Okay, we try to look one by one. When heat is transferred out of the system, the value of Q is positive in sign. Ini salah sebab sepatutnya dia adalah negatif. When a piston is being compressed, the work is done by the gas. Ini pun sama juga, sepatutnya dia adalah on the gas. When an ideal, yang D, we check C first. The change in internal energy, delta U, is mainly dependent on temperature. Okay, this one is correct. So delta U depends on the change of temperature. Kita belajar lah. When an ideal gas expands and undergoes change in volume, there is no work done by the gas. This one is incorrect because work will always be equals to P delta V. So if you have a delta V, then you expect to have a W work. Okay, very good. Question number 2. Which of the following graph indicates adiabatic expansion of an ideal gas?
A sir.
A, okay, very good. So, yang B ni untuk apa? Constant pressure?
Isobaric.
Isobaric.
Salah.
Salah.
Betul.
Betul. Salah ke betul?
Salah.
Supposedly apa? Okay, kalau kita tak sure, we can always check. Okay, if you go back to our lecture notes, okay, this one So, kalau you have tadi apa? Constant pressure. Kalau constant pressure is isobaric. Okay. Kalau constant volume, isochoric. So this one is
isobaric.
Okay, good. Okay, question kalau answer C tu dia adalah
Isochoric.
Yes. And D is
Thermal.
Bagus. Okay, question number 3. Which of the following is a characteristic of an adiabatic process?
C.
Adiabatic process, Q equals to 0. Yes, excellent. A container, question number 4, a container filled with a sample of an ideal gas at a pressure of 1.5 atm. The gas is compressed isothermally to 1/4 of its original volume. What is the new pressure of the gas? Question number 4 apa yang mana?
C sir.
C ya? Okay. You can try to check. Okay, let's try to do the workings. Okay, dia kata ada container filled with sample of ideal gas. Okay, dia kata P1 is equals to, question number 4. P1 is equals to 1.5 atm. The gas is compressed isothermal. So isothermal. If you want to use the triangle, PVT, so T is constant. So you have PV equals to PV lah. P1, V1 equals to P2, V2. Okay, dia kata the gas is compressed. So maksudnya volume dia mengecut lah. Kalau V1 equals to V, okay, that means your V2 is equals to V over 4. Agree or not?
Agree.
Agree, eh? So if I substitute the values inside this equation, so I will have 1.5 V equals to P2 V over 4. Cancel out the V. Your P2 would be 4 times 1.5, which is 6. This one is ATM, so it will be ATM as well. Okay. Okay, any question?
No, sir.
Okay, good. Okay, let's look at question number 5. Which statement about the first law of thermodynamics is correct? Mana satu yang betul? Question number 5.
C tu yang betul.
So you have the equation delta U. Sorry. First law of thermodynamics yang kamu pakai Q. Q equals to delta U plus W. Okay. So dia kata internal energy increase equals the heating of the system. Okay. And the work done on the system. So it comes on because this is a negative sign. It means that this one is on. Okay. So this one kalau positif dia adalah heating. So this one again is positive, it means that this one increase. Okay. So jawapannya C lah. Dia just nak confusekan kamu between the wording tu. Okay. Now, question number 6. Tadi 5 ada soalan tak?
No.
Okay. Question number 6. The work done on or by the gas is work equals to nRT ln V2 over V1. Sketch PV graph for all the thermodynamic process in the same axis below. Okay, dia kata the work done on or by the gas is work equals to. Okay, lepas tu dia suruh sketch je. Okay, this one is actually very similar to the one that I draw yang last tu. Dia macam soalan tu macam tak ada kena dengan yang atas kan. So basically they want you to show
Tak ada
all the
sini.
thermodynamic process on the same axis kan. So I just copy this one lah. Okay. But in exam lah, let's say if they ask, tetapi kamu punya tak ada lukis kan. Kalau dia, ni pun dia kasih lukisan. So kalau kamu lukis, make sure kamu label properly because you cannot differentiate between different color. Kalau dalam exam kan kamu pakai satu color kan. So you have to label properly. So ini saya guna different color, so should be okay. Anyway, this is the answer. Okay, question number 9. Question number 7 we already discussed. 8 also we discussed. We go straight to question number 9. The gas undergoes the following thermodynamic process. Isobaric. Lepas tu compress isothermal. Expand adiabatically. Sketch all the process given. Okay. So if you have this kind of question, kamu dah buat ke belum ni?
Dah cuba tapi saya tahu saya salah.
Oh, okay. Okay, we need, first of all, we need to label the punya process tu. Contohnya kan, macam process number 1, it is a isobaric expansion. Heated, I just copy back at constant V. Okay. Okay, number 2 dia kata compress isothermally and finally expand adiabatically. To initial pressure and volume. Okay, so basically you want to draw a PV graph. So I just draw the axis first. So they didn't say any unit or anything, just label the SI unit. Okay, dia kata first of all, it is a isobaric expansion. isobaric, apa yang constant?
Pressure.
Isobaric pressure.
Volume sir.
Sorry, volume.
Kan? Okay, it's okay. Ya, saya tak tahu. Satu dia sebenarnya ada cakap kat belakang tu yang
Sir, iso
constant
apa?
volume. Isobaric.
Bukan pressure ke? Yang constant. Tu
So
isocoric.
maksudnya dia ada dua
Pressure,
proses
sir.
tadi ya. So pertama sekali isobaric expansion. Lepas tu yang kedua heated at a constant volume. Betul ke tak? Faham tak maksud saya? Maksudnya saya biasanya ada 4 proses. Dari common saya tak perasan. So the first one is isobaric expansion. Okay, and number 2 heated at a constant volume. Now it makes sense. Okay, isobaric is constant P. Okay. Saya sendiri selalu confused at a constant P. Okay, kalau constant P, dalam PV graph kamu, you have a straight line kan? Line kamu tu horizontal ke vertical?
Horizontal.
Okay, kamu kata dia horizontal. So, maybe macam ni lah. P dia ni kan? Okay, now you have to ask yourself, is it to the right or is it to the left?
To the right.
Kenapa? Why do you say it is to the right? Betul, ke kanan. You're very good. Tapi kenapa?
Sebab dia expand.
Yes, expansion indicates that the volume
Volume dia bertambah.
very good. So volume bertambah over here. It indicates that the direction is to the right. Okay. Number 2. Dia kata heated at a constant V. So this one is actually isocoric. Betul
Okay. Isocoric.
Isocoric. Constant V. So maksudnya dia punya line tu ke mana? Vertical kan? So it will be a vertical line. Is it ke atas ke bawah?
Ke atas.
Kenapa?
Heated.
Yes. So the temperature increase because it is being heated. So kamu boleh bayangkan kalau kamu ada the first temperature profile tu, the second one dia akan naik ke atas macam tu. So dia jump daripada lower temperature to higher temperature during the isocoric process. Okay. Dan dia kata compress isothermally. So kalau isothermal, kamu punya pergerakan tu adalah curve kan?
Betul sir.
Yes,
Okay.
sir.
So now you have to ask yourself, curve dia tu ke kiri ke kanan?
Ke kanan.
Ke
Compress
kiri.
maksudnya apa? Okay, volume dia increase ke decrease?
Decrease.
Yes. Yes, turun sikit. So the volume decrease. So kalau volume decrease, dia mestilah daripada besar ke kecil. So ke kiri lah. So in a way, dia akan bergerak macam ni. Juga. And then the last one, kata expand adiabatically to the initial pressure of a volume. Initial pressure and volume. So this one, you expect the curve juga. Tapi curve dia ada jump between the temperature profile. Right. So this one, is it to the right or to the left?
Right.
Sebab volume dia
Expand.
increase. Very good. Okay. Okay, so far ada yang tak faham tak? Ada yang, do you guys need more explanation? Okay. Sekejap tu saya hopefully everyone can understand and everyone can follow. Okay, now we want to combine all these 4 processes into the same diagram. Okay, we start with the first one. So dia kata from the left to the right. So maybe I can draw it like this. Bring it to the light a little bit. Okay. And this one is the first one. So dalam exam, okay, normally kalau dia suruh lukis, you have to label. Okay. And then dia kata the second one is going straight up. And then kata compress isothermally. So if you have the curve, let's say tinggal lah. Okay. So that was number 2. Dia kata yang pertama tadi ke kanan, yang kedua ke atas, ketiga naik atas curve. Okay, like this. Then the last one dia kata compress adiabatically to the initial. So it will be something like this lah. Kalau nak nampak cantik sedikit, so maybe you can bring this one a little bit down there. Okay, so 1, 2, this one is the third process, and this one is the fourth process. Okay, sometimes they might ask you to label the punya apa tu proses tu, nama dia. Just go through again. So yang one tadi tu adalah isobaric, isochoric, isothermal, and then lastly is adiabatic. Okay, so this is the process, and then you still have to label the PV and so on. So in this case you have 3V. Kalau ada nombor tak apalah, biarkan label 1, 2, 3, P1, P2, oops, tak muat, and P3. Okay, berikut ke tak? Okay guys, okay or not?
Okay sir.
Okay. Okay, so kalau dia kata biasanya lah when they ask to draw, normally dia punya proses tu macam satu loop, satu complete loop. Dia pusing balik kat tempat asal, like this examples lah biasanya. Yeah? So you have to draw macam proper sikit lah so that it makes sense. Kalau yang ni tak cukup panjang tadi, so dia akan, bila dia turun tu dia jadi macam curve ke sana pula, so dia tak make sense lah. So dia kata yang last tu dia adalah expand, so volume dia mesti menaik lah. You have to be careful with the word expand, heated and compress. Okay, expand and compress indicates the volume changes, the heated indicates the temperature changes. Okay, ada soalan tak sebelum kita pergi ke soalan nombor 12?
Tak ada sir.
Okay, now we will move on to question number 12. Okay, yang ni dah cuba belum?
Dah cuba sir tapi salah juga.
Salah juga. Okay, a fixed mass of either monoatomic gas is contained in a cylinder. Okay, maybe I can try to draw the cylinder. Inside cylinder is a monoatomic gas. The cylinder volume can be varied by moving the piston in and out. So basically kat atas ni ada piston lah. So this piston can be moving in and out to change the volume. The gas has an initial volume at 100 kPa. Temperature is 100 Kelvin. The gas is cooled at a constant pressure until its volume is 0.06. Okay, constant pressure indicates what types of thermodynamic process?
Isobaric.
Isobaric process.
So?
Isobaric.
Baric.
Okay. So, if you want to take out the information, dia kata initial volume, so V1 ni, this one already in SI unit, so you don't have to worry. P1 100 kPa, this one is a constant. So basically P1 dengan P2 dia sama lah, ataupun tak berubah. Temperature initially is 300 Kelvin. Okay, question A, dia kata sketch a graph of pressure against volume for the above process. So PV graph lah. So A, they ask you to draw the PV graph. Kalau constant pressure, then your graph will be a straight line, horizontal ke vertical. Constant pressure.
Horizontal.
It's horizontal.
Yes, horizontal. Is it to the right or is it to the left?
To the right. Because
So you
increase
put this
volume.
is V2. Dia kata V2 dia kata the gas is cool at a constant pressure until its volume is V equals to, this one is V2 lah, 0.006. So is it expanding or compressing?
Oh, it's compressing.
Compressing.
Compressor.
Good. So this is your V1, this is your V2. Dia daripada 0.01 mengecut ke 0.006. Direction would be to the left. And then the value for your pressure would be 100 kPa. So I can put this one as 100, but I have to change my label here to kilopascal. Okay. If you draw it like this, then you will get a full mark. Okay, make sure bila dia suruh case atau scratch, you still label with the correct values. Okay, now question B, dia kata calculate the final temperature of the gas. B1, they want you to find final temperature. T2, you do have values for V1, V2, P and T1. Kamu nak pakai formula apa?
Formula Charles Law.
Yes, you can apply. Saya tak ingat nama dia, hopefully kalau betul You can apply Charles Law. Okay. Or in other words, you can apply the triangle. Yang Charles Law tu kamu check balik kalau salah betulkan sendiri. So it will be PVT. Okay, apa yang constant? Pressure is constant, so you tutup this one, so you left with V over T equals to V over T. 1122. Okay. Jadi daripada initially dia adalah 0.01. Tengok balik kamu punya graph tu, 0.01, and then the compress to 0.006. Initial temperature is 300 if I'm not mistaken. Yes, 300. So T2 is over here. Okay, so again, even though this one is chapter 14, you apply the concept of chapter 13. How much you get? Temperature.
180 Kelvin.
180.
Okay, very good. 180 Kelvin. Okay. So, macam mana kamu nak tahu kamu kena pakai benda ni? Kalau dia suruh cari macam work done, most likely you have to apply yang chapter ni punya formula. But if they ask you to find something else, most likely you have to apply previous chapter. Kadang-kadang dia suruh cari numbers of mole. Okay, that one you have to apply previous chapter as well. Okay, contoh yang chapter ni, yang B2 tu, work done on the gas. Okay, so this one is not isothermal. So kalau isothermal, you have to apply yang ada lon tu, right? But this one is not isothermal. This is just an isobaric. So you can apply work equals to P delta V. The formula always for this one lah. Kalau isovolumetric, volume doesn't change, then work equals to 0. Tapi ini ada perubahan lah. Make sure you use SI unit. Pressure here is 100 kilopascal. Kilo you have to change to prefix. Pascal is the SI unit. So it will be V2 minus V1. Saya label dulu. And it will be okay. 0.006 minus 0.1. How much you get here?
Negative 400 joule.
400.
Okay, very good. Negative 400 joule. The negative here indicates work done on the system ke by the system?
On the system.
On the system.
Work done on the system. So kalau work done on the system, basically the system is being compressed. Which is make sense lah sebab dia punya volume tu mengecil. Volume dia daripada besar dekat sini becomes lesser. Okay, now question B3. B3 ni dia kata calculate the numbers of mole of the gas. This you kira numbers of mole of the gas. So nak pakai formula apa?
PV NRT.
Yes, you can use PV and RT. Macam saya cakap lah, if they ask you to find work, you have to apply formula in chapter 14. But if they ask you to find mole, molecules, other than that, you can use the previous chapter. Okay? So you have to be careful. You have to use, sebab dia ada few P, dia ada dua, P dia satu, dia ada dua V, and you have to do T kan. You have to use the same pair. Maksud saya, you can use V1 dengan T1, or you can use V2 and RT2. Okay, make sure you use the same condition, sama ada initial ataupun final. Okay, biasanya kita pakai initial lah sebab final tu kita dah kira. Kadang-kadang kita takut kita kira tu salah. Kalau nak search numbers of molecule, you can use PV equals to NKT. Saya tulis NKT if they ask you to find molecules. And then the numbers of mole or numbers of molecule doesn't change throughout the process. Okay, dia memang tak berubah lah, they're constant. Okay, let's say we take the first one. Okay, the pressure would be 100 kilopascal. V1 berapa tadi? Lupa dah. 0.01. Okay, value of R berapa?
8.31.
8.3.
8.31, and this one will be 300. Make sure everything in SI unit. How much you get here? N equals to? 0.4 more. Okay, very good. Okay, ada soalan so far?
Tak ada, saya faham.
Alright, good. So just now, yang before this lah, kamu sangkut kat mana? Kalau kamu buat before this.
Saya sangkut dekat graph sir. Calculation tak ada masalah.
Okay. Okay. Now we're moving on to the next question, which is question 13. Okay, question 13. A sample containing 1 mole of helium ideal gas undergoes a cycle of operations as shown in figure 14.1. Okay, dikasih graph. BC is an isothermal process. So the process from B to C is isothermal. Pressure at A is at STP and pressure at B is 2 atm. So this one is 2. Okay. Katakan saya label this one as P1. Normally we label this one as P1 and P2 because I'm following the arrow. Tapi dia tak cakap dia start daripada mana. Okay, katakan dia mula daripada A. So this one would be your P1. Dia pergi ke P2 dekat B tu. Lepas tu dia pergi dekat, this would be your volume 1 and this would be your volume 2. They ask you to find the temperature at A, temperature at B, and the volume at C. Okay. Question number A, dia nak temperature at A. Kita keluarkan information dulu. Dia kata 1 mol. Itu dia punya apa?
N.
Yes, small
N,
n
sir.
dia adalah 1 mol, very good. Helium ideal gas, so just put helium. Okay, dia kata pressure at A, so your P1 is at STP. STP maksudnya berapa pressure dia?
1 atm.
STP pressure is at 1 atm. Okay. So maksudnya P1 is 1 atm. P2 is at 2 atm. Adalah dekat STP, volume dia adalah 22/4 per mol. So because of the STP, the volume is V1 lah, is equals to 22.4 liter untuk setiap mol. So we have 1 mol, so our volume is 22.4 lah. Now it makes sense. So you can change to meter cube, which is 22.4 times 10 negative 3. Betul tak? 1 atm you can convert to Pascal. You can use 1.01 if you want to. Just double check. atm to Pascal. We use 1.01 lah. Times 10 to the power of 5. So this would be 2.02 times 10 to the power of 5 Pascal. Okay, now you have all the information. A dia, calculate the temperature, you can use PV equals to nRT. So this is the first condition. It would be P1, V1, and you can find the T. Can you just follow or not?
Sir, yang sekata V1 tu
Can
sebab
sir?
dia dekat STP kan sir?
Betul, sebab dia dekat
sir.
STP.
Alright.
Yeah. So bila saya, kalau dia cakap kat STP tu, saya tiba-tiba jadi blank. Saya tak tahu kenapa daripada dulu sampai sekarang. So, kamu jangan macam tu. So STP condition dia kata the pressure dia ada standard dia lah, which is 1 atm. Dia kata kalau dia 1 mol, dia punya volume dia adalah 22.4 liter. So itu yang dimaksudkan dengan STP lah. Temperature dia kita nak cari, this one per N. So 1 lah. So you can try to calculate this one. I got here is 272.25. Did you get the same answer with me or not?
Yes sir, dapat.
Okay, maybe you might have a slight different answer if you use different values for your ATM to Pascal conversion. Okay, it depends on the given constant tu lah dalam exam. Kalau dia kasi 3 decimal place, you use 3 decimal place and you might get a different answer. Okay, B. Okay, now you have the temperature at A. So basically, your graph sebenarnya ada dua curve. Okay, and then the first curve tu adalah your T1. Just label this one as a T1. And the old curve tu adalah T2. Anda memang dia tu adalah T2. Okay, so during the next process, obviously kamu punya temperature changes. Okay, proses yang from A to B tu dia panggil proses apa? Constant volume.
Isochoric.
So correct. Okay, yang soalan apa ni? B. So B, process A to B, thermodynamic process A to B is isochoric, which is constant volume. Okay, so macam saya cakap lah, kalau dia nak suruh cari temperature, kamu boleh pakai formula apa?
PV NRT.
Yes. Okay, sebab now kamu ada pressure constant, volume constant. You do have the pressure 1 and pressure 2. You do have the T1. You can straight away find the T2. So it will be P over T equals to P over T. Okay. So kalau ikut label saya 11, 22, P1 tadi adalah 1.01 darab 10 kuasa 5, 2.02 darab 10 kuasa 5, T1 is 272.25, T2 is over here. Okay, that one is 2 multiply by 272.25. Okay, 544.5.
Sama sir.
Okay, good. Okay, ada soalan tak so far?
So far no.
Okay, yang C pula dia kata find the volume at C. Okay, ni kamu nak pakai apa pula?
Pakai sama boleh juga kan PV NRT.
You can use the triangle again.
Oh,
So kan B to C now is isothermal, constant T. Actually you can use PV equals to NRT juga, tak ada masalah sebab saya rasa cukup maklumat. Tapi saya rasa ini paling cepat kira. You can check lah, boleh tak kira pakai PV NRT semata-mata. So kita ada numbers of moles, sepatutnya boleh, tapi tak sure. PV T is constant, so PV equals to PV 1. So I just put 1122 as well, but the 1 here represent here and the 2 represent this one. Okay. Kalau saya nak particular, then you have to be careful lah. Ni P2 dengan P1 saya, tapi saya ikut yang ni ya. So 11 adalah dekat 2. 2 ATM. Okay, your V1 22.4. Okay, your subscript, you might use a different subscript if you want to, you can use. Tapi make sure you substitute the correct values. Macam saya punya subscript ni sebenarnya berterabur sikit. I think if you label with the symbol ABC, maybe macam make sense sikit. Anyway, Okay, V tu dapat berapa?
0.045.
0.045 meter cube. Very good. Okay, ada soalan?
Tak ada sir.
Ada banyak lagi soalan. Okay, 2 lagi. Okay, let's move on to the next question. Question 14. Dia kata, an ideal gas has undergone two processes, A, B and B, C. 8 kilojoule of heat is supplied to the gas in the process of A, B. Kalau saya nak label, saya boleh label Q dekat A, B. Q dekat A, B is equals to 8 kilojoule. Is it positive or negative? Gas to absorb ke release? Kalau untuk 8 kilojoule tu.
Absorb.
Absorb. Kalau absorb, is it positive ataupun negative?
Positif.
Yes, very good. So it's positive 8 kilojoule dekat sini. And the process BC, 4 kilojoule is dissipated from the gas. Is it positive or negative?
Negatif.
Okay. And then they ask you to calculate the work done for the process AB and BC. Okay, kalau work done untuk AB tu, senang je lah kan. Kalau kamu ada graph, kamu nak kira work done macam mana? Ya tak?
Area.
Yes, it will be area under the graph. Okay, alternatively, you can use formula work equals to P delta V pun boleh, tak ada masalah. So, if I want to use this one, katakan area under the graph. Okay, the green area represent the work for AB. Okay, alternatively, like I told you, you can use work sama dengan P delta V lah. In this case, the area is equals to 0.04 minus 0.02 multiply with the 3. Don't forget the prefix, right? Selalu student terlupa. So this one becomes 0.02 multiply 3 exponent.
6,000.
6,000 joule. Okay, good. Okay, dia tak tanya tapi katakanlah dia tanya. Is it work done on the system or by the system? Based on the numbers.
By the system.
By the system sebab dia adalah positif.
Positif.
But kalau dalam kalau kamu kira area kan, so if you simply calculate the area, you have to be careful a little bit. Sometimes arrow dia ke kiri atau ke kanan, kamu tak consider benda tu sebab yelah kita kira area je kan. So jarak ni multiply with jarak tu. Okay. Tapi kalau kamu nak dapat betul-betul, you really have to use work sama dengan P delta V. So the change in volume tu indicates the positive atau negative, final tolak initial. In this case, the A to B kan, so besar tolak kecil, that's why the number is positive. Okay. If you want to use the area under the graph, and then you want to determine whether it's positive or negative, we can look at the direction. Kalau they expand like this, it indicates that the work is being done by the system. Okay, now it makes sense lah kan? Positive, expand, done by system. Dan apa? Work done by the system. Okay, good. For process BC, paling senang lah. Work BC equals to apa? Area under graph dia berapa besar untuk proses B ke C? Ada perubahan volume tak?
Tak ada.
Tak ada perubahan volume, maksudnya work done is equals to
0.
0. Yes, correct. Okay, that one's for question A. Question B, they ask you to find the change in internal energy for the process A, B and B, C. So kalau kamu nak kira change of internal energy, biasanya ada dua formula je. Sama ada you use delta U equals to F over 2 NKT 2 minus T1, ataupun kamu kena pakai ideal gas equation lah. So ideal gas equation state that Q is equals to work plus delta U. So sebab kamu tak ada mole, kamu tak ada tak cukup maklumat kan, so you have to use this one. Dia kata so cari delta U untuk AB dengan BC. Also dia suka calculate separately lah. So for proses A ke B, delta U is equals to Q minus work. Okay, dan Q tu dia dah diberikan tadi kan. So positive 8 joule, we just have to use this one. Make sure you identify whether it's positive or negative first. Kalau tak kamu salah. So here you get positive 8,000 minus dengan work done untuk AB is basically positive 6,000. So here you get delta U equals to 2,000 joule. Okay ke tak?
Okay. Sama.
Good. For BA, okay, soalan macam ni memang famous. Dia selalu tanya. They give you a couple of process inside a graph and they ask you to deduce the information from the graph. Like this one lah. So you have to be kena kreatif sikit lah. Kena macam, bukan kreatif lah. You have to be really particular about the sign convention ni. Oops. Okay, anyway. Untuk BC, then you will have the same formula. It's the Q minus work. But your Q now is negative, right? Negative 4K. So negative 4,000 minus 0. So delta U equals to negative 4,000 joule. Okay, so the positive and negative here indicates increase or decrease in internal energy. Okay, dia tak tanya tapi kamu boleh cakap lah. Yang first one tu, AB, internal energy increase. If internal energy increase, the temperature increase ke decrease?
Increase.
Okay, very good. Okay, yang tu ni internal energy decrease sebab dia negatif lah. So your T is decrease as well. Okay, maybe kita boleh tengok pada proses tu. Okay, so basically this one ada dua curve. Curve number 1, curve number 2. Okay, untuk proses A ke B, dia jump daripada lower temperature to higher temperature. Temperature increase. Agree with the value that we get just now. From B to C, the temperature decrease because this is T1 and T2 kan. Yang T1 ni lagi besar daripada T2. So temperature decrease. So it makes sense lah. So far everything makes sense. And I think the answer is correct as well. Okay, ada soalan?
Tak ada, sir.
Okay. Last question. Okay, a mass of 5.6 gram of nitrogen gas occupies a volume of 4.6 times 10 to the power of 3. At a pressure of 1 times 10 to the power of 5, temperature is given. Nitrogen may be assumed to be an ideal gas. Okay, temperature is raised from 280 to 81. Make satu je. At a constant pressure. Determine for this temperature change, the change in the volume, the work done by the gas, and the thermal energy required when the gas is heated at a constant pressure. Okay, the whole process is at a constant pressure. Constant pressure, dia adalah
Isobaric.
yes. Okay, kalau salah, kamu tekan je lah. So, kalau saya ada PV graph, okay, you will expect that you have a constant pressure. So, if this is my P, so my process horizontal ke vertical? Line saya horizontal or vertical? Constant pressure.
Horizontal.
Horizontal. So apa pressure dia tak berubah. You have a one values for pressure. So like this lah. Ke kanan ke kiri? Okay, cuba tengok temperature dia. Ke kanan sebab apa? Temperature dia increase. So katakan saya ada dua curve. Maybe saya pendekkan sikit. Saya punya proses ni. So this one is just a sketch. So to indicates lah kamu punya proses macam mana, so that you can identify whether it makes sense or not. Okay, so basically this is your T1, this is your T2. Kalau temperature increase, dia mesti gerak daripada T1 ke T2. So here the temperature increase, so that would be the direction. Okay, dia kata soalan ni nak volume the change in the volume of the gas. So you have V1 and V2. V1 is given. Okay, I take out the information first. V1 equals to 4.6 times 10 to the power of, okay, katakan saya nak tukar kepada meter cube, dia jadi berapa?
-10-3.
Betul. Okay, maybe you don't have to change, maybe you have, but in this case saya tak sure kena tukar ke tak, so saya just tukar, just to be safe. Okay, so how do I change? You have a times 10 to the power of 3, centimeter to meter, you have -6, cube sebab the cube, -2 darab 3, -6, so 3 minus 6 you get -3, good. Okay, the next one, dia kata pressure dia dah diberi, which is equals to 1 times 10 to the power of 5 Pascal. And then the temperature T1, okay, temperature berubah, so you have T1 and T2. T1 is 280, T2 is 281. Determine for this temperature change, the change in the volume of the gas. Okay, kalau kamu ada constant pressure, you want to find the change in volume, macam mana kamu nak kira? Pakai apa?
V/T.
Pakai triangle.
Pakai triangle.
Okay, PVT, constant, pressure constant, so you have V/T equals to V/T. V1, T1, V2, T2. Okay, you have to find V2 first, and then only you can find delta V, because I think the question was to find the change in the volume of the gas. So the change here means they want to find delta V. Okay, delta V is equals to V2 minus V1. First you have to find V2. Okay, so your V2 will be equals to V1 over T1, okay, multiply with T2, and then I got here is Sampai. Okay, yang V dia sebenarnya adalah 4.6. Saya salah letak, saya letak pressure P. So V dia tadi adalah 4.6. Oh. Okay. So I got here is 4.62.
Sama sir.
Okay. Okay, I can find delta V by using V2 minus V1. So V2 is 4.62 times 10 negative 3 minus the 4.6 times 10 negative 3. Should get 0.02. Okay. Times 10 negative 3. Total. Itulah, ataupun 2 times 10 negative 5. The unit will be in meter cube. Okay. Kalau kamu dapat negative, that one indicates that the volume actually compressed. So in this one is positive, it's being expanded. It makes sense lah. Based on kita punya drawing tadi pun sama. The question B, dia kata the work done by the gas. Saya nak kira work done. Now we already have P, V1 and V2. Work sama kan? Adakah ini isothermal?
Bukan.
Bukan. So kita pakai work sama apa?
Pakai yang Q. Oh ni, P delta V.
P delta V, yes. Okay. Alternatively, you can use area under the graph if you want to. So kita memang ada cukup maklumat pun. Sama je. So I use this one sebab saya nak tukar. Tadi saya kira pakai area under the graph. Now I just want to show you what if we use the formula. So that means I have P multiplied by V2 minus V1. Dia mesti final tolak initial. Okay, so positif negatif tu ada maksudnya. Pressure here is 1 times 10 to the power 5. Okay. V2 minus V1 we already calculate. Kalau kamu malas nak kira, tak payah kira lah. Kalau nak tulis, boleh tulis. Okay, this one memang no excuses. You really have to use the SI unit. Kita main. So sebab kita dah kira delta V tadi, saya masukkan je lah delta V. 0.02 times 10 negative 3. Okay, here if you calculate over here in centimeter cube, you have to convert to meter cube inside here. Okay, kalau kamu kira this one got negative, you have to substitute the negative sign inside here. Sini pun kena ada negative tu juga kalau dapat negative tadi. Okay, now you will get two. Sama ke?
Sama sir, tu.
Okay. So I got here is 2 joule. So it's positive, maksudnya apa? Work done by?
By the system.
Yes. Expand ke? Compress?
Expand.
Yes. Saya selalu ulang-ulang benda ni sebab I really want you guys to understand and always ask yourself, make sense ke tak make sense jawapan kamu. So kamu tengok balik jawapan kamu punya kisah asal, ke kanan, volume increase, expand, it makes sense. Okay, now
Sir, tapi kenapa dekat skema lain
skema lain, maksudnya jawapan akhir
jawapan akhir.
Jawapan
Yang
akhir
dekat,
tu biasa.
yang A pula tadi pun lain.
Yang A tu dia letak berapa?
16.4 to the power of
Berapa?
negative 6. 16.4 10 kuasa negatif 6.
16.4 eksponen negatif 6 itu dalam
Meter cube.
meter cube.
Yes.
Ke kita ada salah? Okay, tak apa. Kita habiskan dulu. Jadi saya cek balik mana. Serang mungkin kita ada salah.
Alright.
Okay. Saya rasa kalau salah pun mungkin salah kat conversion tu kot. Method macam okay. Okay, anyway. Okay, we move on to question C. Dia kata yang C tu, the thermal energy required when the gas is heated at a constant pressure. Thermal energy required when the gas is being heated at a constant pressure. Okay, kamu nak cari apa sebenarnya? Soalan nak cari apa? Thermal energy. Simbol apa kamu nak pakai thermal energy?
Delta U.
Kalau delta U, dia adalah change in internal energy. Kalau thermal energy, ada lagi satu apa? Adalah ideal gas equation tu kan? Sorry, ada first law of thermodynamics. Ada 3 benda kan? Lagi satu tu apa?
U.
Apa dia? It's a Q Yes. So soalan dia sebenarnya tanya Q. So if you want to find Q, you can use Q equals to delta U plus W. Okay, you do have the W sebab W sama dengan 7, but now you have to find the delta U. Okay, how to find the delta U tanpa gunakan equation lah. So kalau pakai equation ni kamu kena ada Q kan. So saya selalu cakap ada 2 cara nak kira delta U. Okay, one more things, you can use delta U equals to F over 2. Kamu ada mol kan? You don't have the mole, but they give you the gram dengan gram per mole, so you can calculate the mole lah. So you can use this formula nRT2 minus T1. Okay, this one is from the previous chapter. You have to calculate the N first, and you have to use mass divided by molar mass. Okay, you have to check lah, make sure the mass and molar mass in the same unit. This one. So one is in gram, another one is gram per mole, so should be okay. Kalau satu tu kilogram, you have to change lah. 5.6 divided by 28.01. Betul, 28.01.
Zero point two.
Okay. That's 0.2. Okay, this one actually adalah mass divided by molar mass. Okay, in case you are not sure. Dalam exam pun akan diberilah molar mass tu semuanya beri. So don't worry about it. So F kamu sama dengan berapa? Tengok balik, ni gas apa? So this is a nitrogen gas. Nitrogen gas, dia punya simbol apa? Nak tak?
N.
N ke N2?
N2.
N2. Nitrogen gas is N2, so dia adalah diatomic. F dia adalah
2.
5. Dia
Oh,
3, 5
iya, iya.
and 6. Okay.
Oh, ini yang lepas punya chapter biasa.
Betul, previous
Okay,
chapter.
okay.
Yang lain okey. How about others? Others wujud ke tak ni?
Okay, sir.
Okay, sir.
Okay. Okay, now we already have N, F, R2 is a constant, T so you have as well, so you can straight away calculate lah. So it will be 5 over 2 multiplied with the numbers of mole, which is 0.2, 8.31. So this one is 281 minus 280. That one is 1. So here I got 4.16. Apa tak?
Sama, sir.
Okay, good. So once you have this one, the Q is equals to delta U is positive. Kalau negatif letak negatif make sure T2 minus T1 tu kamu buat accordingly lah. So 4.16 plus 2. Okay, yang basically saya guna formula ni 4.16 yang kita baru dapat. Work ni kita dah dapat before this 2. So that one will be 6.162. Okay.